and make sure certain things are happening, it'll guarantee it each time you'll get ductwork. Okay, so everybody click on solutions. Okay, just follow me step by step. Okay, and then go to perimeter. Okay, now you don't have to use perimeter. That's one of the bits, just so everybody's on the same page. Okay. And then take these settings, so then hit setting, and change both of these from taps to T's. So you want to use rectangular duct, mitered elbows with T's, okay, for your main, and then we're going to do that for the branch. So that's going to guarantee that. So what's happening is we're all of a sudden at a detail, at a joint, that we're going to a smaller, we're mitering down to a smaller ductwork potentially, and then we're trying to cut a hole into that and tap in, okay, which can't happen, right? So if we put a T there, we'll be able to make a custom fitting that does a T to our supply. Does that make sense, guys? The difference? So this will guarantee that this will do this. Then we go to branch, and we want to make sure we're also on T's. So before we were on taps, now we're on T's. And then let's switch our maximum duct length to 2 feet, so it's short. So it's just going from the end to the, it's the part that just connects, pretty much, right? And then we'll hit OK. And then we can inset. I inset the perimeter a little bit, so 6 feet, so it's a little bit more pushed in. Okay, so this is the inset is set to 6. And then from there, I went to Edit Layout. And it says, do you want to overwrite the previous? Yes. And I just moved. You guys might not have this. I mean, it's strange to go up, over, and in. So we can move that. And I can, if you can't snap to it, if it's not gripping to that, you can use the snap and hover over to that line, and it just snapped to that. So you can hover and snap it. And then if you hit finish, it should work. Of course, it'll probably fail on me now or something. Okay, it worked. So you should get 0 errors. Okay? Did that work for everyone? Sorry? Off? Just 2 feet. Yeah, you don't need much to bend in. Although, this is a little skeptical. We maybe wanted to go a little bit longer, but it didn't give us an error, so. That looks like it's definitely not connected. But it didn't give us an error. So maybe 3 feet or 4 feet. You can, go back. Oh, sorry. So we can go back. Solution. Unfortunately, we can't change the settings, so we would have to go back to perimeter. So whatever moves you made, you would have to do it again. And then we can go to setting, branch, and we can make this, let's try 3 feet. And then we can go back to edit. Yes. Pick that guy. Move that to there. Hit finish. Let's see if that looks a little more promising. Yeah, not much. That's fine. Okay? Alright, so after you're done with this, the next step is to, if we hover over one piece of duct and just hold down the tab, not hold down, tab through the tab key. So I'm not holding it down. That's me holding it down, the tab key. What you want to do is hover over one piece of duct, hit the tab key multiple times. That's me hitting it multiple times. I know people like to do this. So don't do that. Tab through. You're adding to the system. You want to grab all the ductwork and then click on it. You just make sure it's good. Okay? Hover over one and then press and depress the tab key until you have the entire, and then click. And then you're going to click on duct pipe sizing. And then for the sizing method, I think we always left it on velocity. This is pretty, is that too much? 1,000 feet per minute? Yeah. Yeah, so there's friction, equal friction, static, regain. Sure. It's going to get small. Yeah, unless we move it really slow. It's pretty fast. The ductwork's going to get really small. We hit OK. How you want. Let's see what happens. Just wait. Let mine do its thing, and then we can always resize it. Boop. So there it is. So that's moving air pretty fast. 1,000, right? Feet per minute is pretty fast. So this is the actual duct size now. Okay. Static regain. So I'm going to pick them all. So I can pick them all again. Hit duct sizing. We can do velocity, and say I'm doing a recording studio, which we did once. We want to move air real slow. Yeah, let's see what happens when we make it at 100. Probably won't be a huge difference, but let's see. A lot bigger. So you understand, moving slow air. So yeah, I did a recording studio, and they didn't want to hear noise of air movement. So you make the ducts really big, move the air really slow, and it costs 10 times as much. Does this make sense? I mean, it's pretty cool. Just size your duct, and it's based on CFMs, right? Like what each room, each space needs. So based on the space requirement, and then how you branched it, right? So this is where you can get into sort of testing different things. Now, obviously, it looks, yeah, I mean, this air is going to slow down quite a bit as it comes out. I'll come around. Let's quickly, so that's where we're ending today. Okay, we'll skip create the camera and create sheets. Okay, we'll do that next week. Yes, yeah, we're gonna go over it right now. Yeah, we're not done. It's on there. So, due on 4/17, create spaces and generate the heating and cooling loads for the final project. So let's look at the final project. Yeah. So let's look at that, and then we'll go from there. Okay. So I'm gonna open that up. And I have to show you one trick. You guys can just watch. Just watch. You guys will do this at home. Is this okay? I know you guys, because we don't have a lot of time, and I want to move pretty fast. So sorry. Yeah, because you have to download it. It's, again, this file is located on the Blackboard Grade school. So let's open up. So I'll open this up. Just look up here. You don't. It's on the blackboard. I'll show it to you if you can't find it. On the blackboard, it's right here under Revit project files. Energy 552. It's the bottom file. Project Revit 2014. All right, guys. This is the file that I just opened. If you want to open it, you're welcome to. I'm not. Okay. It's a little bit big, but it should be fast. So right here, this is the file. When you open it, it looks pretty unsubstantial in the 3D view. I did this on purpose so you guys don't get confused. This is what the project really looks like. You might know this project is actually one of the proposals from DLR that I ended up using. Like dumbed it down to like nothing, but it was based off of an actual project for labs. I don't even remember. It's so old. I did the renderings for. I think this is an old. So this is it right here. You can see from the rendering it has a lot of glass. If we go to one of the floor plans, it's basically has an adjacent building that this is an addition. And then there is glass that wraps this. And then this entire space is a corridor lounge. Okay, so this is where people hang out and communicate. It was supposed to be like these, what do they call those? Accidental, like where you bump into another scientist in another department, and then you sit down and talk and have a Starbucks coffee, and then you come up with a great idea, right? So this is what's happening now in all these places. So a lot of talking. And these are all the different laboratory, office, so there's labs in here, so there's equipment, there's storage, there is a potential mechanical, more storage, bathrooms, there's a stairwell. This is where your shaft is. This is where you can run anything if you want to run it up to the roof. You are working just on one level. You're doing just level 1, okay? You're not doing the entire building. There's 2 levels to this. If we go to a elevation, there are 2 levels. We can also see we have a ceiling level at 10 feet. This ceiling level is only in the labs, okay? It's not in the main corridor space. So you can do it eventually. When you think about it, you can do exposed ductwork and so forth. The first thing you're going to do just like the tutorial. You're going to make the space, just follow the exact same steps that we did in the tutorial for the in-class. You're going to delete any spaces that might be there. Delete them, okay? Start fresh. The one thing that you have to know how to do is, for the spaces, what you're going to run into is you're going to want to probably create 4 zones here, okay? This is not a space, this is actually a room, so don't get confused. Rooms are just square foot, spaces are volumetric. So when we want to come here and create a space under Analyze, we need to make a space separator if there's no walls to create a separation. Okay, so if you wanted to make an imaginary separation within this large corridor, we have to make a space separator. I'm going to show you how to do that. We click on space separator and we draw a line that goes from maybe a corner all the way to the end here. Okay, so this is basically separating that open corridor because I may want to separate this into 1, 2, 3, 4 zones. Each corridor has its own zone because how we might treat the north exposure versus, a west or south might be very different, right? You want to have a different thermostat because here you might be, if you're burning up over here and you're running the same, you might be freezing over here. that make sense? So this separator allows us to make separations in rooms that do not have walls to create separations. So I can do that across. That way when I create, didn't like something there. I think it still maybe made it. Let's see. So that way when I create a space, it's automatically separating it. Okay? Remember, a space, ultimately, if we put it on its own zone, will have its own VAV box in it. We'll go over the VAV box next week, okay? This makes sense? So you're creating all the spaces, making sure and the other thing is we're only going to put ductwork in the first floor. We still need to make spaces for the second floor, okay? Because it's not a roof. So you have to make spaces for everything, including the adjacent building. So when it does the heating and cooling load calcs, it realizes that's not an outside wall. So you have to make, so take a note, you have to make spaces for both first floor and second floor. And then you're going to run the calcs. But we're only going to design a system for the first floor. Okay? Questions on this? You're turning in the calcs then. Okay? Same way you did on this. That's your homework assignment for next week. And then after that, the final turn-in will be on finals week. Again, we'll be reviewing, starting up on making a camera and sheets, and then we're going to go into making these documentations. And then you're basically doing exactly what we're doing in the in-class demo on the project. It's obviously more elaborate. Okay?
Are there instructions for the project?
No. You're a designer. You're going to design it. I'm going to be here to help you. Don't worry. But it's exactly the same thing. You're going to look at the space. What's the CFM requirements? You want to put one big diffuser in the middle? You can. You know, pump 1,000, you know.
Everything on this project that you've done so far?
Yeah.
By next week?
By finals.
Oh.
You're just doing you're just doing spaces and heating and calculations. By next week. That's not a lot. I can do it right now in front of you in about 15 minutes. Maybe less. So, times 10, an hour and a half. It's exactly the same thing you just turned in today. Forgot. That's why you got videos. You're going to watch them. You're going to do it. Okay.